Hello everyone and welcome on today's video. My name is Wouter Peer and I'm the founder and main developer of GHEtool Cloud. And today we will be talking about quite a hot topic. And although you might not believe it, it's not the design of shallow geothermal bore fields, but it's artificial intelligence. But before we dive into the how and why, let us first talk about a problem we are facing nowadays in the world of bore field design. So as we discussed many times in the past, the design of bore fields relies on the simulation and the calculation of G functions, the ground response functions, namely how does our bore field react in the long term. And these G values are really expensive to calculate. And for one simulation, so the temperature profile, it takes around 0.5 seconds. Now, that's not a lot, and that's also no problem at all. But the thing is that with more and more complicated methods to come in the future, like for example now already is the case with our calculate required borehole depth method, we require multiple of these G values, sometimes 10 to 50 of them. And the problem is that our 0.5 seconds easily becomes 10 to 30 seconds and even longer. So we're facing a problem here when we are moving forward with GHEtool and more accurate and more detailed methods. Namely, how can we speed up this G function calculation without compromising on accuracy? Because, we want you to design with confidence, so accuracy is actually key. It's a cornerstone of our software. So how can we speed this up without compromising on exactly that? And that's where artificial intelligence comes into view. Now, I'm no expert whatsoever on AI, and I will also not pose any of my own opinions here, whether it's a bubble or not. But the thing is, and you see that in many sectors, it has a value. Already today, artificial intelligence has a value. It speeds up quite a lot of processes, from medicine to engineering to even language learning, etc. So the thing is, we can use AI for this to help us speed up the G function simulation. But AI is also kind of a buzzword. It's a big term. Everything from large language models to robotics, etc. is under that. And the part of AI that we will take a look at in this video is what's called an artificial neural network. And the goal, or the concept of an artificial neural network, is to mimic the behavior of a human brain, or at least how we think a human's brain behaves. So in this graph, we see a human with a brain, and this brain has multiple neurons, and these neurons are connected by axons, which act as pathways between the different neurons so they can exchange information. And the way we believe a human brain works is we get some inputs as data from our senses. We taste, we smell, we see, and all this information gets passed through our neurons, which pass it around, neuron after neuron after neuron, until we end up with a certain sense, a certain insight, a certain reaction, a certain action. It doesn't really matter. So basically, we believe the human brain works like that. We have certain inputs coming into our brain. It gets passed through a series of neurons until we end up with a certain conclusion, a certain action, whatever. And that's also exactly what we try to mimic with an artificial neural network. So in the computer world, it looks like this, where we have a certain input layer, which can be a list of values, which is the case in most engineering applications. But for the case of ChatGPT, it's a list of words, for example, conceptually. And then we have our neurons. In this case, we have two layers, a blue layer, a green layer. And you can have as many layers as you want with as many neurons as you want for each layer. And the more complex your neural network is, the more neurons you would need to actually make it work. And then we have an output layer, which in our case will be a list of G values, a list of G function values. Now, the idea is that, as is the case with the human brain, we have certain inputs, for example, the number of boreholes, the depth of a borehole, etc. We pass this into our neural network. It gets to the first layer, and there it's multiplied by a certain weighting factor, and then the value is passed on to the second layer, to a third layer, and so forth, until we end up with our G values. So the idea is, like with a child, as a matter of fact, it comes into the world and there is no information in there, it cannot reason. So we need to train our artificial neural network. It is to say, we need to find the right weighting factors for all our hundreds of neurons in our model to give us, for a certain input, the correct output. And that's exactly what we did for a neural network trained on G functions. Now, what we did is actually based on the work of Tobias Blanke from the FH Aachen, who did some amazing research on this topic and who was kind enough to help develop this artificial neural network for GHEtool. So the idea is that we started with quite a big data set. So we trained our artificial neural network for line configurations, for U and L configurations, rectangles and dense bore fields, up to 30 by 30 boreholes. So in the case of a rectangle or a dense bore field, it's 900 boreholes. So it's quite a big data set. We did this for borehole depths ranging from 50 to 400 meters, for spacings from 2 to 10 meters, from borehole diameters from 100 to 300 millimeters, and also for a range of thermal diffusivities of the ground, so a thermal conductivity, let's say. And in the end, we had 6 million different G functions simulated. It took quite a lot of time, and then we put it into the model, we let it train, and we got out an artificial neural network that was trained to give us certain G values when we have a certain bore field design. Now, so far for the theory, there are quite a lot of measures to see how good an artificial neural network is, but what I believe is the most interesting for you is that we just ran it over 9 different cases, bore fields which are limited by the maximum or by the minimum temperature limits, with some varying fluid parameters, with some geothermal fluxes, etc. And what we saw is that for all these 9 different cases, our results are pretty much alike. Sometimes it differs, sometimes it's exactly right. But overall, in these 9 cases, we saw that our result was within 4% of our traditional method to calculate the required borehole depth. So our ANN performed extremely well for these different cases. Now, what is even more interesting, and the reason why we do this all, is when we take a look at the speed. So of these 9 cases, we see that our ANN model performed way faster than our traditional approach to simulate this calculate the required borehole depth. And we saw that depending on the different cases, whether we included a geothermal flux or not, whether we included variable fluid properties or not, etc., we saw that it was between 25 to 75% faster with this less than 4% of deviation from the actual result. So this is really interesting. So how do we now move forward? Because we have this AI and GHEtool cloud. And what we did is we implemented it. So as we speak, it's already available in GHEtool cloud, but currently only for the aim calculate required depth. It's where it can be such a time saver. And when you select calculate required depth in GHEtool, you will see under the aim specific settings, We have the temperature-dependent fluid properties, which we discussed in the past. We have now use AI acceleration. And by default, it will be off. But if you say yes, then we will use this new method, this new model to speed up your simulation. And we're really curious to see what you think, or if you find some edge cases where it still behaves a little bit weird. But from our simulations we did, we're rather confident it will give you good results. But this, of course, is only the beginning. We said we need this model to keep enhancing our toolkit, to keep creating new methods that are very computationally intensive. And next week we will release such a brand new feature, and it's perhaps the most demanded feature. We will be releasing it right at the end of this year, and it's related to the automated design of boreholes or bore fields, namely the number of boreholes as well as the required borehole depth. So stay tuned for a video next week. Share this video with your colleagues, friends and families, other AI nerds perhaps, and I'm looking forward to seeing you in our next video. Take care. Bye.